This is a video for how to assemble the snail cam into our Automata Box project and animate it. So here's the deal. The snail cam with the tangent constraint is a problem. OnShape doesn't like sharp corners or edges, and unfortunately, the snail cam's profile presents a lot of problems. There are several different ways to solve this, and you'll find some solutions on YouTube, and you're welcome to look them up. But I wanted to make sure that we were able to preserve our parametric equations when we assemble it because it allows us to edit on the fly in our assembly, which is a very powerful part of CAD modeling. So on our box assembly, you'll notice that I have the cam kind of already situated um, because quite honestly, I forgot to delete it. So I'm gonna go ahead and delete that cam out of the place so we're not getting confused. I have made both edges, box edges transparent so that I could see a little better. What we're gonna do is we're gonna go ahead and insert that snail cam. We are gonna find it here. Now, for some reason, when I did my parameters, they're all messed up. So I do want a 2-inch snail cam. My hole is going to be 1/4 inch, and my thickness is still going to be the 0.188. Generate, and I've got my snail cam that I can click and place into my model. Next, what we are going to do is we are going to mate it on. We are going to use fasten mate. I am going to use the outside face with that blue line. Ooh, this may be a problem. Let's see if it works. Yep, so I had the blue line facing the wrong way on my snail cam. Let's see if I flip that primary axis, which is our Z axis, it does flip it in, which is fine. So I'm good with that. And now I need to, oh, I forgot to offset it. So I'm going to go back down into my browser. We're going to offset to, what is that? 1, 2, 3, 4, -4.25. Look at 0.125. I can't remember. Solve it, and that puts it pretty close to where we want it to be. I'm going to go ahead and accept that. And this time, what we're going to do is we are going to assemble just the follower, not the follower assembly. What I've found is that as much as I want our roller to work with the snail cam, it just doesn't. And to be honest, when we go about assembling these in real life, the roller and the snail cam combination do tend to present some problems. So even though we are having some problems animating graphically, there are some problems that present in real life. So let's go ahead and find that follower. And I think, let's see, follow around. There we go. Click to place. And we are going to use our slider. I'm going to mate the bottom of my follower to the very, very bottom of my follower guide. Click to accept. We are going to set some limits and let's see what it does. So my minimum would be -1.25. My max is going to be 0. We're going to go ahead and solve and test it out before I accept those constraints. So it does, let's see, maybe I have to accept it. No, something's going wrong with my slider. Oh, that's because I set the limits on the wrong slider. These are all real life things. Let's try this again. Click to edit my slider, set my limits, -1.25, max 0, solve. Let's see if we can test that. And so I can go up. Ooh, those limits didn't set. That's what I was afraid of. Okay, so see, I always want to test. This is not quite right. It means that my values need to be backwards. So instead of doing negative like I had been, my max is going to be 1.25. And let's see if that'll work. So that's good. Maybe we make it 1.5. And there we go. Okay, so I'm good with that. All right, so now what we're gonna do is let's just try to see what happens when we do our tangent constraint on the bottom of this follower to the profile as it is, and you'll see what's up. So tangent constraint, I want to get that very bottom of my follower guide and see how I can't get through to that. So what I'm going to do is I'm going to make that side transparent. And now I can get to that bottom edge. And then I'm going to choose the profile of my cam. I'm going to accept that. And let's try to animate. So animate, go to crank revolute. And we're going to do 150 steps, add a loop. See how it gives us that warning that there was some error with the steps. Now I'm going the wrong direction, so maybe if I flip, let's see what happens. Yeah, see how it hops there? It's like, hey, I don't know what to do right here. That's a problem. Let's see if I do 300 steps, what happens? Yeah, not a good look to go through that cam. So that's the problem, is it doesn't like all those sharp drags and edges. So what we're going to do is we're actually going to modify that snail cam. And one of the ways we can do that is we can click, double click, edit in context. I guess that was just a single click. And we are actually going to apply a fillet. So let's see if I can do, there we go, more normal view. We're going to add a fillet that is dependent upon our nominal diameter that we've set here in the constraints. I am going to set this fillet radius equal to hashtag D times 8. So my diameter divided by 8. Accept that. And I do need to do these separate fillets separately, I have found. So I'm going to do hashtag D divided by 8. Hit enter. Accept, and let's see what happens with that profile. I may have to go down and reassign that tangent constraint, but right now it seems to be doing okay. Even though it is kind of stuck. So what I'm going to do is I'm going to delete that tangent constraint and we're going to reapply it just to make sure. Tangent constraint, bottom edge, to the profile of the cam, hit OK. Move this to the center so you can see it a little better, and we're going to animate and see what happens. Animate. We're going to go in a loop. And will it work? We're going the wrong direction, so let's try that again. So it's traveling, traveling, traveling. It seems to be doing okay, and it drops. And it's following that profile. It does get a little glitchy right there, but to be honest, I'm okay with it as long as it doesn't blow up on us. This snail cam has been a little on the difficult side. So it's not a true snail cam in the sense of what we get with our laser cutter, but it does mimic the same type of motion at the top. Not too shabby. So there you are. You have your fully animated and done automata box. So proud of you. Way to go.